This covers the new SensoPart VISOR firmware update 1.19. We're going to cover the new features in this firmware update. To update the firmware from our PC configuration software, it's pretty simple. In SensoConfig, you click File, then Firmware Update. And be aware that this will delete all jobs in the camera, so you have to perform a backup first. And to do that, you go into SensoConfig and click File, Save Job Set, and in parentheses you can see it says Backup. All the part numbers and article numbers for the visors have remained the same, as did the pricing. Existing job files can still be used. They'll get updated. So after you back up your jobs, you update the firmware, and then when you click on Start Sensor again, it will update all the jobs in the camera. So you have to download the new PC configuration software from the website. And new visors are going to ship with the CD with this 1.19. And this software will work for previous versions of visors all the way down to 1.16. So if you have to support visors older than that, we have this separate legacy add-on. So after you install the configuration software, you install the legacy, and you can configure and support visors from the beginning of the product family. This is a summary of the new features. The VISOR framework applies to all the visors, and we've got some improvements for each different type of visor. Visor object, visor color, visor code reader. You can see the all-around includes the features of the object and the code reader. So let's start off talking about these features highlighted in blue. Calibrations available in these visors. The ones that have a caliper detector also have calibration. Except for visors over about a year or two old, something with the math coprocessor, we can't do calibration on those, but you can still update to the latest firmware and take advantage of all the other new features. This is a summary of all the new features for 1.19. VISOR framework at the top applies to all of them. And there's some features for each different type of visor here. For visor object and visor code reader, those obviously apply to the all-around. And the all-around has a couple of additional features of its own. Then we've got some new features for the visor color, and we added BLOB to the solar visor. Let's start with these items highlighted in blue. First up, improved edge alignment. So our edge alignment now is better than our EyeSight fully programmable smart cameras. And it's more powerful than visor competitors. And it can now take into account the angle of an object up to about 20 or 30 degrees. We've got these 5 detectors now. We only had 2 before, 1 probe or 2 probe. Here's an example. Parts getting fed on a conveyor. So the conveyor belt's at about a 30-degree angle to the camera, and the parts are moving through the field of view at about 30 degrees. So New feature number 1, we can rotate our alignment detector to be in line with the path of the conveyor. And the second new feature is we can still calculate the angle deviation from that probe. Next, we have this search direction bidirectional probes. And what this is for is to find the center line, as you see here, between these two pieces of metal. Or if you had bottles and of varying diameters, you could still find the center line of the bottle. This is a close-up. You can see the crosshairs where each search stripe found the edge of this part, and it laid down this best fit line that's not perfectly vertical. And similarly, you can see this other best fit line, and that's how the new probe finds the rotation. So which one of these do you use? Well, how many probes do you need? First of all, just one. Is the part only going to move, like on the conveyor example, if the part's only going to move up and down on the conveyor, you could get away with one probe. And then the second question is, do you need to know the rotation information? Previously, when you used an alignment, it applied to all detectors. Now you can switch off the alignment. So for example, if you have a 2D code, that detector can already read the code regardless of its location or orientation. Similarly, the blob, you often don't need alignment on the blob. But many of the other detectors, here looking at the gray, if we're looking to find if a fastener is located in a particular location, for that detector you will need the alignment. Repeat mode with shutter variation. We had repeat mode before where here it's set to 3, the default's 1. If it's set to 3, when you trigger the camera and it fails, it'll retrigger again. If it fails, it'll retrigger a third time before it gives up. And the new feature is to change the shutter speed with each subsequent trigger. These factors you can set. So a factor of 1 means our shutter speed was set to 0.5 milliseconds. So if we change our shutter speed, because of the factors, our variations will change accordingly. So here's an example at 0.5, at 0.375, and 0.25. So it's great for shiny parts or parts with variation, or if you've got varying ambient conditions, if you've got a lot of dust. For plant engineers and other people supporting a lot of connected visors, this new feature in SensoFind is for you. And the new feature is you can save the visor to a list of favorites, such as this. And here you can see if you have a favorite that's not connected, it'll appear light gray, but it's still on the list. Next up is a job template. So imagine you have some standards. You have a calibration, or here perhaps you have some I/O configured for repeat job enable on the yellow wire, and 2 job change bits. Maybe you want your statistics always reset on start only. You could have like Ethernet IP and maybe want SensoWeb enabled. your telegram you probably would want set to ASCII. You can select these options of detector results, which almost everyone wants. You could send the digital outputs to the PLC. And your payload, you may want the general counter pass, counter fail sent to the PLC for every job. And other things like the image recorder fail, which lets you view the 10 most recent failed images in SensoConfig by clicking this camcorder icon. Or if you're archiving images as a standard, all of these custom features you can save as a template, and you do that by setting all those features in the job shown here in line 1, and you right click on the job and it displays this menu, and we have this new Save as Template option. And when you click Save as Template, you get this new row shown here as A. That's the job template. Once you have a job template, all subsequent jobs will pull from that. So here when we created job 2, in step 3, all of those parameters from the template were copied. Well, what parameters? Everything under the job setting, everything under the alignment, everything under the detectors, and everything under the output got copied from your job template to new jobs. Next, there's a lot of commands you can send over Ethernet for a lot of adjustment of parameters. You can change the region of interest of particular detectors. You can change the shutter speed. And now you can back up and restore configurations. You can upload and download jobs. You can upload and download firmware over Ethernet. So if you have a standard model of VISOR, you could write your own scripting so that when you replace it, you could load the correct firmware and load the correct jobs for that particular operation. We have a C# viewer. When you install our software, this is the path. This is example code for people who have their own HMI, PC-based HMI, and they want a live view option. Here's the source code to let you do it, and we have this compiled executable you see here as an example. New for Ethernet IP, we've got an add-on instruction that will send strings to the code reader. So shown here in green, if we want to change the expected code, we can do that from the PLC, and the detector will fail if the code does not exactly match that reference string. So we have some new documentation. We've updated our Ethernet IP quick start and our step-by-step and our summary document. And these are in the path shown when you install the configuration software. So the example programs for Rockwell are broken up into 2 now. We've got one with the new send string and the job change and the trigger, and another one for just the job change and the trigger, because if you're not using a code reader, you probably don't need the send string. This summary document shows where your data ends up in your PLC. The discrete outputs reflected here, logical outputs if you use them. Detector results are really used by almost everyone. You do have to check the box in the payload telegram tab. Payload bits start at 92, payload strings start at 116, and payload integers start at 244. So Down here, if you don't have a Rockwell PLC, this is all the information you should need to configure Ethernet IP for your controller. Next up, VISOR object, contour and blob updates. For the contour, there's a new tab, multiple objects. So this can be used for counting. As you see here, there's 5 objects found, and you've got location and angle information for each one you can send to a PLC. In this example, we're looking for exactly 9 parts. Within the field of view, we can set the number to exactly 9. And if we find only 7, the detector fails. And again, the position of each part, of all parts found, can be sent to a PLC or robot. For blob, there's a circle fit. This will take any object. It won't work well for squares or rectangles. It does work for arcs, for partial circles. If you have a quarter of a circle, as we'll see in a bit, it lays down a best fit line. You'll see the green line, and then you can calculate from that best fit the center of the circle, the radius, and the amount of deviation inside, or the amount of deviation outside, or the average deviation from that best fit line, like plastic injection molding short shot. Here's an example. We have this circle, and it lays the green best fit line, and you can see here the deviations. There's the radius, deviation min, deviation max, deviation mean. This compactness was an existing feature. That means how round is it? If you have a given area, the smallest shape is going to be a perfect circle, perfectly compact. So compactness of a value of 1.0 is a perfect circle. So this is close. Here in this example, we've got like a burr on a machine part, for example, and you can see we've got an arc. This is just part of a circle, but it laid the best fit line on that, and you can see the deviation is quite large because of this burr. If we were only looking at the area of the object with a traditional blob, this amount of deviation wouldn't be enough to call it a bad part, just looking at the change in the area. But here, again, we're looking at the deviation from this best fit circle, so we can find this. Code Reader Auto Tune. It's here. In the Code Reader Detector, you may know about this Teach Initial button, which sets these parameters in these tabs for that particular code. And if you have subsequent codes, once you teach one, this will say Teach Additional, and you can teach additional codes to add the parameters, adjust the parameters for each new code. That's what the Teach Initial does. Auto Tune does something different. It sets parameters such as shutter speed and pre-processing filters to be able to get optimize the code reading. So when you click Auto Tune, you get this dialog box. By default, you have pre-processing, and you're going to try these various filters. You could also vary the gain, and if you have external illumination, you could check internal and external illumination for it to try those options. If you have our polarizing filter, you could enable that. We have a polarizing filter where half of the internal lights are polarized and half are not. Here's an example with a really hard to read code. We'll create a data code detector and move the search region and click Auto Tune, Start, and here we go. After Auto Tune, we click OK, and the code's red. VISOR Color has new virtual color filters. So we have our color detectors, color value, color area that remain the same. All of the other traditional detectors on a color camera now have additional color filters. Here's an example we'll look at. We've got text on a multicolored background. Some of the background's light, some is dark. It's really hard to do an OCR with that image. Traditionally, we could choose one of 3 color models, and you could pick a color channel: gray, red, green, or blue. So with this image, the new feature is a color distance filter. So you can see how much more vibrant this image is compared to what we had before. Again, here's the original image, and here's the next filter we have: binarization. So obviously this is much easier to read than any of the prior images, as shown here with our OCR detector. Some applications include the OCR we just saw, or to optimize edge detection for calipers, or luminescent adhesives, or Loctite under UV light. Now we're to the new features unique to the VISOR All-Round. First, the contour alignment has a gripping space feature, where if you're using it for a robot, you can make sure that there's room around your target for the gripper, that if you have the parts or the wall close where a gripper couldn't go, you can check for it now. This is kind of a preview of our upcoming robot camera later this year. The other new feature is this calibration plate. You can purchase this or print out the PDFs that come when you install the software, and this combines the best of the accuracy of a calibration plate and the alignment of the robot coordinates with the VISOR coordinates that the point pair list gets you.